Hi guys, I introduce myself. My name is Adriana, and in this video tutorial I'm going to show you how to solve a differential equation of first order, and then we will graph it in MATLAB. I would like to start with an introduction of what is a differential equation. A differential equation is an equation that relates non-trivially to an unknown function and one or more derivatives of this to an unknown function depends on a single variable. The differential equation is called ordinary. On the contrary, if it depends on more than one variable, it's called partial. The non-trivial phrase we have used in the previous definition has the purpose of discarding differential equations that satisfy the definition, but they are really identities. That is, they are always true no matter who the unknown function is. An example of such type of equation is the next. Sinus squared dy on dx plus cosine squared for dy on dx is equal to 1. This equation is satisfied by any function and a variable that is derivable. Another example is dy on dx less y squared is equal dy on dx squared less 2 for y for dy on dx plus dy on dx squared. It's clear that what is behind this equation is the remarkable formula a plus b of square is equal the first square plus double the first by the second plus the second square. Well, we'll start with the example. The one we're going to present is going to be the next one. Cosine of x for dy on dx plus sinus of x for y is equal to 1. Clearing the equation dy on dx, we obtain dy on dx is equal to 1 on cosine of x less sinus of x on cosine of x for y. We know that 1 on cosine of x is secant of x, and sinus of x on cosine of x is tangent of x. In this way, we reduce the equation, this product. Between to the manual equation, we came to the solution. Now have to check if the same things happens in MATLAB. The solution: y of x is equal cosine of x for tangent of x plus cosine of x for constant 1. Open the MATLAB. In command window, we enter our function already clear y of x with the following command: y equal dissolve parenthesis apostrophe dy it's equal sec x less x for y come x is y. This equation is equal our solution. We propose an initial condition that is equal to 1. In this form, copy this equation, propose the function, and y equal to 1 apostrophe. This result cosine of x plus cosine of x for tangent of x, it's a new result with the initial condition. Now appear this equation, we open a new script. In the menu and the copy and the paste the function of the differential equation with the initial condition. This is open the new script, Ctrl V. We're running the solution without this. In this form, well, to obtain the equation, we're running the solution and solve with a different number name. It's without space. In this part, my name is this, and appear in this part. It's the equal equation, and this part we're running this form. We're running solution will appear again, and we're passing below the equation so that we will use in the graph. That's okay for graph. And this, okay. This part is no problem, don't consider. It's important put the point for no solve this equation for the graph. Way, make a vector x equal that part from 0 to 0.001 to 100 in this part. X equal to 0, 2 points, x point 1, 2 points. This vector. This means that for each time one make a vector of that number, that makes my y equal to this as a substitute until I reach 100. This intention. I'll make graph the vector x and the function and y. I'll put this comment, plot x, y, r. It's the color, red in this case. After put x label, independent variable, y label, it's dependent, it's x, y. Now put the title, is solution of differential equation. Okay, in this part on curve, now run it and appear the graph. One moment. This part is dependent of variable y, and independent variable it's can be visualized but we change the magnitude of x by 20 in this part, 20 for, as we can observe, when it's equal to 0, y it's 1 in this part. We can observe when x is equal to 0, y is equal to 1 in this part. This is the solution equation of the system of equation with its graph. It's like conclusion, it's something easy, but the program of MATLAB it's so very difficult, but it's really interesting. Thank you. I am Adriana, and thank you for saying. Bye.